Okay, so now let us move on to the week 7 live session. Many of you are still joining, that is fine. Okay, let me share the screen, and once it is visible to you, let me know. Yes, good evening. Can you see the slides? Please tell me in the chat box. So as I have already mailed all of you that today's week 7 live session will be a bit easier. The question will be a bit easier because most of them are based on memory, like you already have all those answers in the slides. It's not like you have to calculate many things or like that. So it is possible that week 7 questions will be finished within 30 minutes or 40 minutes. It will be finished. So after that, as I have mailed all of you, that we will move forward with numerical question from week 1 to week 7. Okay, I have included some numerical question. We will start solving them. To be more specific, that I will not be solving them this time. This time you have to solve it, because I have already taken all those live session and told you that how you have to go with the numerical. So all of you will try to solve them, and then I will show the answer. So that will be today's class. So first let us start with week 7 lecture session. Okay. So this is the first question from week 7 lecture materials. The first question is, arrange the following polymer processing processes according to shear rate. What are the polymer processes? The processes for polymer processing are compression molding, injection molding, calendering, and extrusion. These 4 processes are given. You have to arrange them in their order for shear rate. Okay, nice. So I have already many answers. As everybody is saying it, so the correct answer was D, because obviously if we go back to the slides where Professor Dhara has discussed about the shear rates of different processes, then you can see that these 4 are the shear rates of different processes. One second. Like for compression modeling, it is 1 to 10 second inverse. For extrusion, 10 to the power 2 to 10 to the power 3 second inverse. For calendering, 10 to 10 to the power 2 second inverse. And injection molding, 10 to the power 3 to 10 to the power 4. So our correct option was option D. Okay. So it was purely a memory based question. You have to remember some of the parts from the week 7 lecture materials. This is your second question. The most appropriate processing technique that may be applied for producing the following polymer product. So this is your following polymer product, and what processing technique you can apply to make this. Okay, so I have already have 3 answers. Okay. Some are saying B, some are saying C. Okay. What others think? This kind of question will be important for your exams as well. So I have another answers A. So there are different kind of answers like A, B and C. So all of you do know that extrusion will not be applicable for this particular particular polymer that is shown here, this particular product. Okay. So there are 4 C's, 2 B and 2 A's. So let me show you the correct answer. The correct answer was C, thermoforming. So what is the basic difference? You all know that extrusion process won't be helping in this particular case. Now in case of injection molding, the process actually deals with complicated polymeric structures. Like we have to get a like complicated and very particular type of structures, then you go for injection molding, because it is a very difficult process, you know. And in case of blow molding, you kind of take a polymer material and uh, create some walls by blowing the inert gas into it. So it can form some structures like cylinders, like bottles, etc., like big plastic jars, etc. You are blowing the inert gas and you are making some walls. So this is for blow molding. Now what is for thermoforming? So if you do remember, thermoforming was the only process where you take the plastic to a state where it's not completely melted, but you slightly elevates its temperature so that you can work with it, so that you can deform it to a certain extent, but it's not completely melted. And once you get to that state, what you do, you press a mold onto it. And suppose look at this particular product structure. You are first getting a semi melted kind of situation of your polymers or plastic materials. Now you are placing a mold on it, and once you place the mold, you can create suction so that you can get deformity around that molds. Okay, so this was the purpose for thermoforming, by which you can create shallow holes or sometimes deeper holes as well. Okay, so this is the process how thermoforming works. So according to the structure that is given here, you can clearly see there are some shallow holes in this particular product. So we can say that this was formed by thermoforming process. You actually need to go through the steps of the process, that how it works and what kind of structures different processing techniques can give you. Okay, so this was mentioned in the slides as well, as much I remember. So this is the correct answer was thermoforming. Okay, so let us move on to the next one. It states a BPA polycarbonate sample is completely non-cross-linked amorphous polymer. Among the following, the appropriate processing technique or techniques that are generally applicable to this sample is or are. This can be a MSQ question, so you have to choose accordingly. Now the important point, here is, it has mentioned it is non-cross-linked amorphous polymer. So while giving your answer, keep that in your mind that it is a non-cross-linked amorphous polymer. So in case of amorphous polymer, what kind of techniques we can choose? You have to answer that. Can you show question number 2? Okay, I will go back after we are done with this. I will show the question number 2 again. Okay, I have got one answer. It states A and D. Okay, another answer A, C and D. Okay, last answer C. Another answer is C. Okay, again there are a mix kind of answer everyone is choosing. Let me show you the correct answer and then I will discuss. Okay, so the correct answer was non-cross-link. The correct answer was extrusion blow molding and injection molding that can be applied in this case. Why so? Because if you remember the processes that can be, there are two major classification in case of polymers when Professor Dhara discussed. Okay, one was your thermoplastic, thermoplastic, and another one was your thermoset. So whenever you face this kind of question, first you have to identify what kind of polymer you are dealing with. Now in that case it is mentioned that the BPA polycarbonate is non-cross-linked amorphous polymers. So what does it mean? What kind of polymer you are dealing with? Then you are dealing with a thermoplastic, obviously, because in case of thermoset we know that there are cross-linking happens, only after that we can get thermosets. So the polymer that you are handling is not a thermoset but a thermoplastic, right? So only in case of thermoplastic these uh, these techniques or these processing techniques can be taken, like extrusion blow molding and injection molding, etc. This is very obvious as well, because in case of thermoplastics only, because it is much more flexible, when we are giving heat you are kind of melting it, but when we are removing heat it can go back to its original shape, right? It can go back to its original state. That is the whole purpose for thermoplastic, but you cannot do that with thermoset. That's why with thermoplastic, by this blow molding on injection molding, these processes can be applied, because you can mold it to different shape. You can heat it, you can mold it to different shape, and once you decrease the temperature or lower the temperature, it will go back to its original state by maintaining its shape as well. This is the advantage what thermoplastic gives you. So these extrusion blow molding and injection molding, these processes are used for thermoplastic. Now if you do remember the slides, the processes that are used for thermosets are compression molding. Okay, the main process that is used for thermosets are compression molding, because only in that case you can get a like a flowy, like, because thermosets are cross-linked structure, you cannot mold it or you cannot stretch it as you wish. Okay, so after in compression mode you can get a certain amount of fluidity by which you can mold these structures. So compression molding is specifically for thermosets, where in case of rubber it is specifically called calendering. Okay, when we are dealing with rubber, then we call it calendering. The separate process was mentioned in the slides as well. So I hope the confusion was clear. So do remember the techniques which are used for thermoplastics and thermosets, and in this kind of question identify your polymer, whether it is thermoplastic or thermoset, and then you can easily identify which processing technique you have to use. So I was asked to show you the question number 2 again. So this was the question number 2. So the question was that you have to form this particular polymeric product, which processing technique you can use to create this particular polymeric product. So the correct answer was thermoforming. So if you have any doubt who asked the question, you can later ask me, okay? Or you can see the video when I upload it as well. So let us move into the question number 4. So it states, time dependent behavior of elongation deformation is monitored by which of these following tests? Okay, there are 4 steps, 4 different tests are mentioned below. Which of them defines time dependent behavior of elongation deformation? Okay, this is the 4th question. So 2 answers are B, 1 answer is D. Another answer is C. Okay. So let me show you the correct answer for this particular question. So the correct answer was B, that is creep test. Because if you go back to the, this question you have to actually remember that what is the name of this particular test. There is no other way than that to remember. Like whoever answers the other things like hardness, someone answered the correct option is D. But in hardness test or hardness measurement, we test the resistance to surface indentation. So that is not asked here. Hardness measurement is a different thing. And in case of fatigue test, we can get the lifetime or durability of your material, right? So fatigue test is also not the correct answer, those who answered C. And the correct answer was creep test. It actually gives you the time dependencies of elongation, which is otherwise known as viscoelasticity. Okay, so creep test was the correct answer for question number 4. This is your fifth question. So it states, for a given polymer, increasing degree of crystallinity should decrease which of these parameters? You are increasing degree of crystallinity, that will lead to the decrease of which of these parameters? Okay, so I have 3 answers, 4 answers. A, okay, fine. Okay, I think so everybody does know the correct answer for this. So the correct option was transparency, because you do know that whenever you are increasing the crystallinity of crystals, what happens when you pass light through them, the diffraction increases too much. When you are increasing the crystallinity, the light gets diffracted, so the transparency that you want, that is hampered. So crystal transparency means the light has to pass through the material, right? But the more it becomes crystalline, the more its tendency to refract the light. So it will decrease the transparency of the material. Okay. Let us move into to the sixth question. The ability of a sample to sustain a dead load is quantified by which of these following parameters? The ability of a polymeric sample to sustain, or any sample suppose, to sustain a dead load. By which quantity you can quantify that? Okay, I have one answer, B. So I have so far 2 answers. They are saying B. Okay, let's see what others are thinking. You have to remember the, or look at the stress versus strain curve, and then you can answer this question. You simply have to just look at the stress strain curve and the answer will be clear to you. It is talking about dead load. Another answer is also B. Okay, others also please try to think what can be the answer. Just look at the stress versus strain curve. You can take help of the slides as well, but try to understand what particular point it is, point on the stress strain curve it is talking about. Okay, some answers are D and C. Okay, So again kind of a mixed answer. Many of you said B. I have got one answer C and one answer is D. Okay. Others have any opinion? If not, then I will show you the correct answer of this. So the correct answer of this particular question was tensile strength. But as many of you answered different things, let me explain it again, that why different kind of and what you are getting wrong in understanding this particular stress versus strain curve. So there are many points. The options are elastic modulus, tensile strain, yield point and area under the stress strain curve. The answers that I have got: tensile strain, C that is yield point, and D that is area under the stress strain curve. Okay. So first of all, if I look at this option, the C, yield point, why it won't be correct? Because yield point is generally your identification when it goes from elastic states to plastic state. So here initially you have your linear elastic state. After some point, one second. So initially you have your linear elastic state. After some time it will go back to non-linear elastic state, and when from this elastic state to is this plastic state will start, this particular point is marked as yield point. That is basically your transition from elastic to non-elastic state. So that is not what is asked here. Sustained dead load means up to what point, up to what point it can it can resist the stress, and beyond that particular point it will simply rupture. It will no longer be able to hold it. That is called your dead load. So what will happen after yield point? You have your plastic form. When you are increasing the strain is increasing. That means you are getting your elongation, but the stress is not increasing that much. But once you reach this point, this point is known as your dead load. When beyond this, when you will apply more stress or more strain, you will try to elongate a plastic fine. To certain stage it will elongate, but after that when the strain is too much, it will simply break. Dead load means the same thing, at which point it will the specimen will rupture. Okay. So what by what quantity you can identify this? You can identify this by tensile strength, because tensile strength means what? Tensile strength is basically the deformation that is happening in the strain. You are applying stress and the sample is suppose elongating. That is your basically tensile strain. According to the vertical axis, the deformation that is occurring, that is your tensile strain. And at a particular point, when you are still trying to stretch it, at a certain point it will just break and deform. So from the tensile strength you will be identify that what is the dead load, that what amount of stress a particular specimen can bear. After that it will simply deform or rupture. Okay, so the correct answer was tensile strength, not yield point nor area under the stress strain curve. I am not explaining about that point because I think I have a question about that particular question. I will that particular point, so I will explain that later. So this is your seventh question. Which of the following factor will increase the TG? So there are four options. You have to identify which of the following factors will increase the TG value or glass transition temperature value. Akash, you have asked me a question. I don't understand what exactly you are asking about. But if it is a assignment question, then I can't directly give you the answers. But I think you will be able to get your answers from the next questions. Okay. If you do know the answer, then why you are asking? Okay, fine. So the options they are saying are A, B and C. Some are saying A, B, D. Okay. Increase in the TG value. A, C, D, A, B, D. So A and D are almost same for everybody. B and C are like varying. Okay, then let me show you the correct answer. The correct answer was A, B and D. Why so? Because if you look at all these points, first point is presence of polar functionalities in the backbone and or side groups. You do know the more polar functional groups you are giving, like more polar groups you are giving, you are actually uh, increasing the interaction between the polymers. TG means when you are transferring it to a glassy state to a rubbery state. So the more interaction between the polymer will be there, it will be more difficult for you to separate them and take them to a rubbery state. So polar functionalities means there will be many kind of factor, many interactions, many hydrogen bonding interaction and many thing will come in account, which will increase the TG value of your ultimate polymer. Next point was increasing stiffness of the polymer backbone. You also in the slides there are many examples that as you keep on increasing the stiffness, the more it will try to remain in the glassy state. You will have to increase the temperature to a higher extent to get rid of that, to make it to a flowy rubbery state. It is obvious, like, because glassy state your stiff glass state is your stiff state. So more the stiffness, more the temperature you will require to make it to rubbery or flowy state, right? So B option was correct. Next was presence of long plasticizing side groups. Now you already know that plasticizers are generally used to make to increase the space between the polymer molecules. That is the work of plasticizer. So as you increase the side groups, the size of the side groups of plasticizers, the free volume between the polymers that gets increased, and as you increase the free volume, obviously the TG will decrease. In our case it was asked that which of the factors will increase the TG, so obviously long plasticizing group will decrease the TG because of increasing free volume. So option C was not correct. And lastly, option D, introduction of cross linking. So the more cross linking you impose on your polymer sample, that means your polymer sample is becoming stiffer. Okay, it will be more in your glassy state. So harder, it will be much more harder for you to break those cross linking and to take it into a flowy rubbery state. So obviously cross linking will increase the TG value or glass transition temperature of your polymer. So this was question number 7. Let us move on to the next one. Okay. So it states, for a semi-crystalline polymer, which one of the following is the most appropriate? So there are 4 temperatures that are mentioned. TG is glass transition temperature, TD is thermal decomposition temperature, TC is your crystallization temperature, and HDT is your heat distortion temperature. So these are the 4 temperatures. I think HDT is not mentioned anywhere in the option, so just focus on these 4. Tg is your glass transition, Td is your thermal decomposition, Tm is your melting, crystalline melting temperature, and Tc is your crystallization temperature. These are the 4 temperatures. You have to arrange them in the order, so that for a particular semi-crystalline polymer, which of the following will be most appropriate. HDT is not an option, so you don't need to think about it. I have some answers D, some answers are A. Again, somebody is asking me the question from assignment. Sorry, I cannot give you the answers for your assignments. You have to solve your assignments by your own. If you do want to know the answers, then stick to this session. I believe you will be able to solve this question or answer this question by yourself at the end of this session. So stick to the session, follow the questions that I am giving here, and you will be able to answer it. But I cannot give you the answer of assignment directly. Sorry. Okay, so again a mixed amount of answers I am getting. C, D, B, A. It's many answers again. So see, although these questions are pretty much like taken from the slides itself, and you have to remember many of them, but still there is a need of understanding that what these all temperatures or what every term means, because if you don't capture all these points, that what are the things or what they mean, you will be not be able to answer the question. Although you have to memorize, but still you need to first understand what this means, and then you have to memorize this particular terms and everything. Okay, so let me show you the correct answer and then I will discuss. So the correct answer was D, that is the order, the lowest temperature is Tg, then Tc, then Tm, then Td. Why it is so? First of all, is what was making everyone confused. Okay, it states that it is a semi-crystalline polymer. So there will be some amorphous region like this, and there will be some crystalline domains as well. So we all know when this kind of scenario appears, first look at what are the temperatures. We have first Tm and Tg. Okay, these are the frequently used temperature terms. So what will happen for Tm? Tm will appear only in the case of this crystalline domains. They will give us Tm, and these amorphous domains will give us Tg. Now what will be their value? So you think that for both of the case, like for Tg, what you do? Tg means you are taking from glassy state to a rubbery state. Fine. Same for melting temperature as well. You are taking it from a crystalline state to a liquidy state or liquid state, right? That is your melting temperature. So in both the cases, you are like giving the temperature to take it from a hard or stiff state to a more flowy like state, right? So if you think in case of this crystalline domains and non-crystalline domain, in which case it is more stiff? Obviously for the crystalline domains, they are much more stiffer. This has to be because they are much more arranged. There are much more interaction between the polymer molecules than in case of the amorphous one. They are just randomly arranged or randomly entangled with each other. But in case of the crystalline ones, they are properly arranged. There are many interactions that are happening because you are properly arranging them. So you have to give a much more higher temperature to distort that particular conformation to take it to liquid state. whenever you are taking them to liquid state, that means you are increasing the randomness of your system and take it to a more flowy like random arrangement. But in case of crystalline state, it is perfectly fine. It has perfect interaction, it has perfect atmosphere for itself. Then if you still do want to take it to a flowy and higher random structures, a state with higher randomness, you have to give much more temperature to take it to that compared to Tg, because Tg was already kind of random, right? So if you want to take it to a flowy state, it will require less temperature than in comparison to your crystalline state. So obviously your Tm will always be much higher than Tg. Once we understand this, definitely we can say that this option was wrong. We do not have to consider it again. So the what are other options left? That was B, C and D. Here it is correctly mentioned that Tg is less than Tm. Okay, in all these three options it is correctly mentioned. And for the last temperature, that is your thermal decomposition temperature, you know that decomposition temperature means it is just an irreversible change. You are just decomposing the whole polymer. Okay, so there are, it cannot revert back to its original state again, so you are totally decomposing it, so it will require the highest temperature. So that was obvious to all of you, and that's why in all of this option Td was the highest temperature. All of you know that. Now we come to this particular temperature, that is crystallization temperature. Now Professor Dhara has mentioned this in his class as well. What is this crystallization temperature, or there is a process known as annealing, that is, you try to impose some amount of crystallinity in a amorphous polymer by increasing the temperature. Generally what we do, if we look at the curve for temperature versus this Tg and Tm, crystalline and non-crystalline state, we are generally decreasing the temperature and slowly reverting to different states of a polymer. But in case of crystallization temperature, what we are trying to do, we are trying to impose some crystallinity in a amorphous polymer from outside. Okay, so for that what we do, we give certain amount of temperature. Why do you do that? Because let me explain it. How TC can impose crystallinity. Suppose your polymers are entangled like this, too much entangled, but to attain your crystallinity, they need to have certain amount of fluidity in them. If they do not flow, then they cannot rearrange. If you give some amount of temperature and get some amount of fluid texture, then only it can try to arrange certain parts of it to a crystalline domain. Not all of it, but certain parts of it can arrange them in a crystalline state. For that what it requires a mobility, right? It requires to flow. So obviously if the temperature is below Tg, your polymer is hard, your polymer is like glass, brittle like behavior, like, right? So there is no option for you to crystallize it. But if you increase the temperature higher than Tg, then you are imposing a fluidity in your polymer networks. So now they are not fully entangled like this, but they are separated by certain amounts, in which regions the polymers can try to crystalline themselves. So you are not taking it to the melting temperature, you cannot, right? Because it will not get fully crystalline. Obviously you cannot achieve that, but you are giving a certain temperature that is higher than Tg, so that it starts to flow and certain parts of it starts to crystallize. That is why your crystallization temperature always lies between your melting temperature and glass transition temperature. So annealing or crystallization temperature, annealing is a particular process where you provide heat from outside, the temperature is in the region between Tg and Tm that will impose a certain amount of crystallinity in your polymer. So what, if you do understand up to that, so what should be your correct answer? That Tc should exist between Tg and Tm. So both the option B and C were wrong, right? So the correct option is D, where Tg is the lowest, Tc is in between them, that some amount of crystallinity has been imposed. Tm means the polymer is crystalline polymer, so Tm will be very high, and Td will be the highest because it is your decomposition temperature. I hope the concepts for Tg, Tc, Tm and Td is clear. Okay, fine. Let us move to the next question. So it states, consider the following two polymers with similar molecular weight. Okay, so again the point is very important, that their molecular weights are similar. Which of the following statements are correct or is correct? It will be is, a particular option will be correct. You have to get an idea about the glass transition temperature and melting temperature. So obviously, as it has both Tg and Tm, so you know it is a these polymers are semi-crystalline polymers. So you have to identify what will be the order for Tg and Tm for both these polymers with similar molecular weight. I have one answer, C. Okay. Another okay, another two answers, C as well. Others also please try to answer. Remember what factors do affect Tg and Tm of polymers, and then you will know. If you understood the last question, you can easily just cross out two options according to the Tg values. Okay, so most of the answers are C, so very good. Obviously, you know, one second. First of all, the Tg values of polymer B will be much more higher than in case of polymer A. Why? Because you are having a phenyl group instead of your CH2 whole 4, right? So whenever you are having a phenyl group, that is giving much more stiffness to your polymer than your CH2 group, because CH2 bonds are each CH2 bonds are attached to each other via a single bond, and whereas in case of phenyl there are pi bonds. So this is much more rigid, much more stiffness in the polymer is occurring. So Tg of polymer B will be greater than Tg of polymer A. So at the very beginning you can cross out these two options. And now coming to the melting temperature as well. So this is also the same reason, because again melting temperature means you have to get the crystalline domains to a flowy liquid state. Now whenever there are much more stiffness, it will have a much more tendency to form crystals. Like rather than this particular CH2 whole 4, the phenyl groups will have much more tendency to stack among each other and to form a crystalline domain. So in case of that, you will need higher temperature to break those kind of interaction and take it to a liquid state. So the Tm of polymer B will be higher than Tm of polymer A. So your correct option is C. Okay, so this is the next question. It states, which of the following thermodynamic parameters change discontinuously on heating a polymer beyond this glass transition temperature. So there are 4 thermodynamic parameters given below. Which of them change discontinuously on heating above Tg? You have to remember this. I have one answer. Everybody please kindly mute yourself. Okay, so what answers I am getting? One answer is D, one answer is B. It is fine. I am just saying that just mute yourself. That is fine. Again, mixed answers. B, C, D. Many mixed answers. Again, C. Everyone should know this answer of this particular question because it is clearly stated in your slides from the lectures. But if you haven't understood that the points that why they are changing or what kind of thermodynamic parameters are changed with Tg or Tm, then you won't be able to answer this. You will be confused. Okay. Okay. And I one answer C and D, another answer D. So again, kind of a mixed answer. So the correct answer was, so far I think only one person has given the correct answer, that is C and D. Both of them are correct. So you already know this, but again let me explain it for those who haven't understood. So volume, second option was enthalpy, heat capacity means your Cp, and coefficient of thermal expansion means alpha. So first of all, you also need to know their symbols as well as what they are called, because in some cases in the exam it might happen that the symbols are given and you don't know that Cp means heat capacity or alpha means coefficient of thermal expansion, then you won't be able to answer it. Okay, so remember their symbols as well as their meaning. So it has asked that which of the following thermodynamic parameters will change discontinuously on heating a polymer beyond this Tg. So as we all know, Tg, the transition at Tg is a second order transition or second order transition. So when do we call a transition a second order, and what happens in case of second order transition? It is very much simple. You have, for any kind of transition, whether it will happen or not, it solely depends on what? The delta G value of any reaction. Let me write the thermodynamic equation for delta G. Let me write it as dG, VdP minus SdT. So any kind of reaction, whether it will go forward or not, it will be decided by your Gibbs free energy value, the change in Gibbs free energy value, that will decide the fate of your reaction. So if the transition that is happening, when we say that it is a first order transition, that means the first order derivatives of G are changing discontinuously. Okay, and in case of second order transition, we means the second order derivatives of dG or Gibbs free energy changes discontinuously. So what does this exactly means? So we all know that dG or Gibbs free energy is actually a function of temperature and pressure. And we all also know this thermodynamic equation, that dg is equal to vdp minus sdt. So what does this first order derivative means? So dg is a function of temperature and pressure. So the first order derivative will mean del g del Tp, that is you are changing temperature keeping your pressure constant, and another can be del G del P T, that is your change of Gibbs free energy with pressure keeping your temperature constant, because it is a function of temperature and pressure. So we can calculate this once we can calculate the change with temperature, and once we can calculate the change with pressure. So now this is your equation, dg is equal to vdp minus sdt. So when you get this derivative del g del Tp, you will end up with what? V. Del g del Pt is equals to V. Simply again del g del Pt will be equal to minus S. S means your entropy. So whenever a transition is first order transition, these changes like volume and this entropy, these changes will be in case of discontinuously will be changed in case of your first order transition. Why? Obviously you can see that by del g del Tp we get V, by del g del Pt we get entropy. So these will change discontinuously for first derivatives. For second order reaction, what you need to do? You need to get a double derivative. Okay, del 2g del T2 and del 2g del P2. Once you do that, you will end up with this equation. In one equation you will get Cp, which is otherwise known as your heat capacity, and in another derivation you will end up with this, where alpha is your coefficient of thermal expansion. So in every case of second order transition, they will change discontinuously. So now if we look at the changes here, what have been given here, the options that have been given here. First option was volume. Volume can't be true because Tg is our second order transition. Okay, and we know that V or volume comes from first order derivative, so that cannot change discontinuously in case of second order. So volume is wrong. Same thing goes for enthalpy as well. This is also a first order transition or first order derivative, so it will not change discontinuously in case of second order. So enthalpy is also not the correct answer. So the rest of the options were heat capacity and thermal expansion. So we do know that the second order derivative gives us heat capacity and coefficient of thermal expansion. So in case of second order, these two particularly will change like this. This will be dotted. I mean there will be a discontinuous change. If we plot them, like if you plot Cp versus temperature, then you can get something like this. Okay, second order derivative will be discontinuously changed. There will be discontinuity between these two. Fine, let us move to the next one. Which of the following statements is or are correct? That is asked in your question. So I think now all of you can answer this. It is an MSQ type of question. Which of the following statements are correct? If you have understood the last one, it is very easy. Okay, I have got one answer, A and C. Very good, A and C. Okay, now it seems that all of you have understood the concept behind it. So the correct answer of this particular question is A and C, because in the last question I just mentioned that glass transition temperature or glass transition is a second order transition. Fine. So our option A is, one second, our option A is correct. Now in case of B, polymer melting, that is associated with Tm. Melting temperature is not a second order transition, it is a first order transition. So the second option is incorrect. Third option is there is a change in the heat capacity, that is delta Cp at glass transition temperature. And what we saw in last question, that in case of second order transition, which parameters does change discontinuously? Cp changes discontinuously and alpha changes discontinuously. And this is exactly stated in this option, that there is a change in the heat capacity at Tg. Obviously at Tg there is a change in heat capacity, I just showed. So this will be kind of your value for Tg. If you plot Cp versus temperature, then at this particular midpoint you can get your Tg value. Okay, so the third option was correct as well. So correct answer for this particular question was A and C. Fine. So this is question number 12. To increase the extent of crystallinity in the polymer sample, which of the following steps you should consider? Okay, this is a very good question. You need a very basic understanding that in what condition you can get or impose crystallinity in a polymer sample. One of them I have just explained a few questions earlier, and others just think of it. I think you will be able to answer it. This is a very good conceptual question. Again, I am mentioning this multiple times. I won't be answering any assignment question during my live session. And as I do make the question, I do remember most of the questions that I have given in the assignment. So more or less I can understand that, or which of them you are asking are from the assignments. I can pretty much recognize them. So I won't be answering them at all. I can answer similar questions, but I won't be answering the questions at all. Okay, so I am getting answers like C and D, A, B, C. Okay, C, A and D, again a mixed kind of answer. Fine. Everyone please try, and after that I will explain it. Obviously I will explain it, but others also please try. Again, two answers are C, two answers are C and D. One answer is A and D, another answer is C and D. Okay. I want others to answer this particular question because this is a very good question. Online calculator, there is no option to put e to the power 2 or 10 to the power minus 4. Okay, actually last time we have checked, there was option, I mean they showed us the calculator that you can use. There we saw that you can use e to the power or 10 to the power things, because they also provided us with the calculators, right, to check that what kind of questions we can make, and e to the power was available there. But let me go back tomorrow and again make sure. Okay, so this is fine. I will again ask Professor Dhara to check it once again, that whether e and 10 to the power, these are available in your calculator or not. Okay, I will make sure to ask him once again. Okay, and then I will post a message in the group in case if these options are not there. Okay, so coming back to question number 12, the correct answer was C and D. I think okay, 3 of you was able to give the right answer. Okay, I am coming back to the calculator issue a few minutes later. First, let me clarify this question and then I will tell you. Okay. So the correct option for this was C and D. Why so? Look at the first option. It states annealing at a temperature below Tg. In the previous question, I just mentioned that what is your annealing or crystallization temperature that lies between Tg and Tm, right? Because if you are trying to impose crystallinity below Tg, how can you do it? You first need to make the entangled polymer molecules somewhat free, somewhat flowy, so that it can flow and some part of it can come together and form a crystal-like domains. So if it is below Tg, how can you get that? You cannot get that flowy motion that is required to crystallize your polymer. So it states annealing at a temperature below Tg. So obviously, can it be done below Tg? No. Crystallization temperature is always greater than Tg. So the first option is not correct. Coming to the second option, stretching at a temperature below Tg. Again this thing, another option other than annealing to impose crystallinity in a particular polymer is by stretching above Tg. If you look back at the slides, then Professor Dhara has mentioned that another way by which you can impose crystallinity, if you just stretch suppose a polymer at a temperature that is greater than Tg. Obviously, you have to get a higher temperature than Tg, because only under that condition it will go from a glassy to a rubbery state. And when it goes to a rubbery state, when you are stretching, you are kind of aligning the polymers, right? So some parts of it will start to form a crystalline domains, because you are just stretching and kind of aligning the polymers with each other. So by that you can impose crystallinity. But in this particular option, it is mentioned stretching at a temperature below Tg. Below Tg, it remains as a below Tg, it remains as a glass that is just like shows a brittle like behavior. How can you stretch a glass? You cannot, right? Below Tg, how can you stretch it? So that option is everyone can please mute yourself. Please, everybody, please mute yourself. 1 second. Oh. Others, it's a request again, please mute yourself. If you have any query, then you can ask me in the chat box. Currently, please mute yourselves. Otherwise, it will be very difficult for me to discuss. Okay, if all of you are done, then can I go back to the questions? The all the queries about your exams and everything, please. I am reading the chat box. I am reading the question. I will let you know if I know the answers of your queries. Currently, please keep. Uh, don't unmute yourself because that becomes very difficult for me to explain. You all will not be able to hear it. So it's a request to all of you. Please do not unmute yourself without asking. Okay, please do not do that. So if you can see it, let me go back to this particular question. As I was saying, see, that's actually hampers. You are still audible, whoever is speaking. Can you please mute yourself? Otherwise, I will not continue this class. I'm very sorry. Please mute yourself. Okay. Let me go back. Sorry for the disturbance. Can you see the slides? Can you all see the slides? Okay. So before getting back to these questions, it's a request, as I've already said many times, do not unmute yourselves, and if you do not, if you're not able to understand the question, you can ask me multiple times. I will answer them. Still, if you don't feel that I am not able to answer your question or not understanding anything, you can contact the professor directly as well. I am trying my best here to describe to everybody. So let this particular session clear to those who are interested and wants to understand. Okay. So back to the question. So as I was saying, that the second option will not be correct, because obviously you cannot stretch a polymer below its TG, because below its TG it is like a glass. So if you try to stretch it, what will happen? It will simply break. Nothing can happen other than that. So obviously your option B will not be correct. Okay. Next option is slow cooling of molten polymer. Obviously, this is the primary example or the main process how you can form crystals. Not only in case of polymers, in case of anything. What you do is you slowly cool your melted polymer samples. Melted polymer samples means your chains are already not entangled that much. Like the previously entangled state, it is not that much entangled because you have already melted it, you have given the temperature. So there is a difference or there is a space between these polymer molecules. So now when you are slowly cooling this, you are giving them the opportunity to come closer at a particular formation. They can come close to each other at a particular formation so that it can form crystals. So always slow cooling is very much important. If you just cool it rapidly, then what happens? You don't give it sufficient time to arrange themselves. You are just hurrying the process. So you are not giving them sufficient time to arrange the polymers. If it does not arrange among themselves, they will not be able to form crystals. So slow cooling of molten polymers are always important to form your crystallinity. Okay. Next is evaporation of polymer solution. Again, evaporation is a very slow process. What you are doing, you are slowly evaporating the solvent. You have your polymer solution and you are slowly evaporating the solvent. And as this process is slow as well, whenever the solvent molecules are evaporating, you are giving sufficient time for those gaps to be filled. How they can be filled? Like the in between the polymer molecules there are solvents. Now they are slowly evaporating. That means you are again giving those polymer molecules sufficient time to come close to each other and form some kinds of arrangement so that it can form crystal. So again, evaporation of polymer solution can lead to formation of crystalline domains. Okay, I hope this is uh, fine. Yeah, I will give you a break. That is not okay, fine. It's already 8:16, right? Okay, fine. Then you can we can take a few minutes break. Say I will be back at 8:25. Okay, you can take some break, and I think for question week 7 session there are only 4 session left. I mean 4 questions left. So we'll be able to solve them. Let us take some breaks. And about the calculator, who are asking, first of all I will make sure that the e to the power and 10 to the power things are present there, and about how to use the calculators. Now see, I don't know if some of you have given any online exams like NET, GATE or JAM, then you will be the calculator will be similar to that as well. And for those who haven't, it is pretty much same. There are some things that are different. What we'll try to do, I will contact the NPTEL team so that they can send you a demo for that. Okay, because I don't have that, these technical parts I don't handle, but I can ask them that students have this kind of query, so if they can give you a platform to practice it before your exam, so that will be beneficial for you, so you won't be losing your time in understanding the calculator. So I will ask them if they can provide you a demo or something like that. Okay, so where you can go and practice the calculator. I will ask definitely tomorrow. I will ask them. Okay, so for now okay, so for now let us give a bit when we'll get the exam center. I actually don't know about that. Okay, because these things I don't handle. I am only the TA. I am only to hear, to give the questions, solve the questions and everything. Nothing about the technical parts, but yet I can look at it. Probably I will ask Professor Dhara. Maybe he might know these things, or the NPTEL team, as I am contacting them for the calculator, I can ask them as well. They will be able to answer these questions. Okay, so I will ask for the exam centers and for your calculators issues as well. Okay, thank you. So let us take a break. I will be back at 8:25. Okay. Okay, so should we start the session again? It was a small break, I know, but okay. Can we start? Can everyone listen? Am I audible to everybody? And can you see the slides? Please confirm in the chat box. Then I'll start. Okay. Okay, so let us move on to the next question. Question number 13. So this is again a very good question. So I want all of you to think it properly and answer it. The question states the value of glass transition of the following three polymers are given below. Generally the Tg values are given for all these three polymers: polyethyl methacrylate, poly N-propyl methacrylate, and poly N-butyl methacrylate. Basically the chains are increasing from ethyl to propyl to butyl, and these are the corresponding Tg values. Now they have asked what is the Tg of polyisopropyl methacrylate. I should have mentioned much more, like what should be the closest Tg value for polyisopropyl methacrylate? I have already 2 answers. Very good. Is this was discussed in lecture? I don't know. If it was, then also fine. Okay, so everybody is giving the correct answer. So the correct answer was 50 degrees C. I think everyone know the answer. Again, just quickly let me discuss this. So obviously you can see these are the 3 polymers. Those who are not understanding, for them I am explaining. So for Tg value of isopropyl methacrylate, you have to calculate. That should be higher than your N-propyl methacrylate. Why? Because in case of what? N-propyl, this is like a chain. But in case of isopropyl, it is like this. In case of N-propyl, this is CH2, CH2, CH2. 3 CH2 groups and so on. But in case of isopropyl, it is like this. So whenever you are transferring it to isopropyl, that means you are increasing the steric hindrance to the polymer. So the more you increase the steric hindrance, the Tg value will increase. So the Tg should be greater than the value for your poly N-propyl methacrylate. Next option is it should be less than polyethyl methacrylate. Why so? Again, if you think it, like polyethyl methacrylate has a less chain, less amount of side chain, I mean smaller side chain, that is ethyl, compared to your isopropyl, right? So in case of that, in case of your polyethyl methacrylate, the site if you consider it as a plasticizer, so in case of ethyl group, that will have a much, that will impose a much more higher Tg value than in case of your isopropyl methacrylate. The same thing, because it is ethyl, it is isopropyl methacrylate in your case. So obviously the Tg value should be less than ethyl methacrylate. So now you have your answer that the Tg value should be greater than 38 degrees centigrade because of the steric hindrance, and it should be less than your polyethyl methacrylate because of the concept for plasticizers, right? So only one option is there which is between 38 to 65 degrees centigrade, that is your 50 degrees centigrade. So the correct option for this question was A. Okay, so this is the force. I think this is the last question probably. So it states Tg values of polymer A and polymer B are 150 degree and 100 degree centigrade respectively. What will be the Tg in degree Celsius of a random copolymer of A and B containing 20 weight percentage of A and 80 weight percentage of B? So you have to calculate Tg in degree centigrade using Fox equation, that is also mentioned, of the random copolymer that is prepared by A and B, where A is 20 weight percentage and B is present as 80 weight percentage. Okay, calculate this, and once you are done, tell the answer in the chat box using Fox equation, and tell me the Tg value in degree centigrade. Don't forget this part. Okay, so I have one answer, 107. Remember your Fox equation, that is 1 by Tg of your copolymer is equals to Wa Tgb. All the values are provided, the weight fractions are provided, the corresponding Tg values for A and B are provided. You just need to calculate the Tg value for your copolymer. Yes, temperature you can convert it to Kelvin or not, but the final answer should be in degree Celsius. Tg for Fox equation is actually the temperature is given in Kelvin, so you can convert them in Kelvin and calculate, and then finally make sure to convert it to degree Celsius again. Come on, this is a pretty straightforward mathematical questions. Why only one people has answered so far? You have everything that is stated here. The weight fractions are stated, the Tg values are stated. You just have to put them and calculate the Tg for copolymer. I have written the equation as well. Okay. In minus? No, it will not come in minus. I don't think it will. Okay. So the correct answer range was correct answer should be 10. I don't know. I have got it 109. There might be some calculation error in this case. I don't know. But the range was given from 107 to 111, and most of you has answered 107. So obviously this was our formula. Now let us see the weight fraction of polymer A is 20%. So we can write it is 0.2. Weight fraction for polymer B is 80%. So that will be 0.8 minus 273. No, okay. Okay, fine. Yes, you have to finally minus 273. Now you have to convert the Tg value for polymer A is 150 degree centigrade. So you have to I think polymer A 150 and polymer B is 100. So obviously we have to add 273 to convert it to Kelvin. So once you add 273 to 150 and put it here, and add 273 to 100 degrees centigrade and put it here, and you now just have to calculate Tg of your copolymer. That will come something, and after subtract whatever value you are getting in Kelvin, subtract 273 from it to convert it to degree centigrade, and you will be ending up with this particular value or a range about 107. Okay, so this particular question is very important. Let me tell you again, it is similar question is in your assignment as well, and it will be important for your exams as well. Okay, so remember these questions. This will be important for your exams as well. Okay. Okay, I see. So these were the questions from week 7. We have finished the question, all the question. It took much longer time that I anticipated. So now just I have said, so we will start solving numerical problems from week 1 to week 7, because it is very necessary that you do remember all the things that you are learning. You are not forgetting, because you have to remember everything, and the questions will be the question will come from every week's lecture, not like your assignments. So we will be solving some numerical questions from starting from week 1, and I will give you like 5 minutes or 2 to 3 minutes depending on the question, and then you have to tell me the answer. Okay, so let us start with the first question. So it is your a hypothetical sample of polycarbonate is composed of a series of fraction of different size molecules. Okay, the similar type of problem. So we have our different weight fraction and their corresponding molecular weights that are given in this chart. Now they have asked us to calculate number average molecular weight. Be very careful to see that what values are given in the table and what they are asking. Here they have provided weight fraction and the corresponding molecular weights. Okay, but in the final question they have asked us to calculate number average molecular weight. So be very careful with these things. Last question. To convert into Kelvin you have to do minus 273. Okay, so to convert anything, any degree centigrade to Kelvin, when you are converting degree centigrade to Kelvin, you add 273. Okay, that is the natural convention. And when you go back from Kelvin to degree centigrade, that's when you subtract 273. That's why 0 degree centigrade is not equal to minus 273 Kelvin. 0 degree centigrade means 0 plus 273, that is 273 Kelvin. Whenever you are converting degree centigrade to Kelvin, you have to add 273, not subtract. Okay. Yes, you can ask your questions in the chat box, but again, if it's about an assignment question, then I won't answer that. If it's something else, then yes, you are free to ask any question, or suppose regarding the marks as well. If you have any query, then I will be answering your questions. Okay, I have one answer, 4317. Let us see, at least let us get 3 to 4 answers, then I can move on to the next question. Okay, I have got another answer, but it is very much different than the first one I got. Come on, this is one of the easiest question. Okay, we are doing this kind of questions from week 1, so you all should be able to answer them. This is one of the very first questions that you all learned in the class and in the session as well. What happened? What happened to everybody? Why they aren't answering this particular question? You have all submitted the assignments, done these questions multiple times. As you have all submitted the assignments correctly, then it should mean that you all know how to solve this kind of questions. Okay, fine. Let me show you again so that it helps you in your exam. So this was your question. So we were provided with weight fraction and the corresponding molecular weight. Now they have asked us to calculate the number average molecular weight. So how can we correlate number average molecular weight with weight fraction? So this was your formula. Mn is 1 by summation of Wi by Mi. And now you see everything is your provided. Wi is your weight fraction and Mi is your corresponding molecular weights. Everything is provided in your question. If you do know this equation, there is just a piece of cake, this question. You just need to calculate Wi by Mi for all these corresponding fractions. From 1 to 6, you calculate Wi by Mi. And then what you need to do? You need to take a summation of all of them. Summation of Wi by Mi. So the formula is 1 by summation of Wi by Mi. Your answer, Shobhanika. What answer you are talking about? Shobhanika. What answer you are talking about? I cannot understand. Okay. Yes, your answer was correct. It should be in a range. Like I haven't provided you the range here. I just giving the question. Yes, but yes, your answer was correct. The range, as we have discussed, that you increase the range in case of exam, so the range will be like in between 12,000 is suppose 12,100 to 12,700 or something. The range will be somewhat like that, or suppose 12,000 to 12,600, something like that. Shesha, what answer? You haven't provided any answer for this question, Shesha. I can only see two answers. One was 4317 and one was 12101. Okay, I cannot, same question, but you haven't given me any answer. What answer did you get? There should be a range. I am just showing you this. There should be a range, suppose from 12,000 to 12,000, suppose 600, 12,600. So if your answer falls in this range, then that will be correct. Okay, fine. So let us move. Told me same as molecular versus same as molecular. Uh, Tail MW. Acha. Okay. Sorry, I wasn't able to understand your question. So you are telling me. So what happens? If they have asked you to calculate the MW. MW, if they have asked, then that will be much more easier for you, because what is the formula for MW? MW is summation of weight fraction Wi into Mi. So if they have asked for MW, so instead of doing Wi by Mi, you need a column where you calculate Wi into Mi for each of these fractions, and then you take a summation of all of them, and that will be your MW value. That will be much more easier, right? Okay, I hope your query is cleared. So let us move on to the next one. I think we can only do up to this question. So it again states what values we are provided with. The dispersity value or the polydispersity index, anything you can tell, that is given as 1.5. The number average molecular weight of the above polymer sample is given here as well. You have to calculate the Mn value. Okay, so the Mn value you have to calculate, the PDI value or dispersity value is given, and you are provided with weight fraction and molecular weight. So these are in your hands. So now you need to calculate Mn using the dispersity. You can calculate Mn like the previous equation, like as was shown in previous equation as well, like doing 1 by summation of Wi by Mi. But my point of giving this question is try to calculate the Mn value from the dispersity value that is given. Okay. Please do remember to calculate your Mn value from the dispersity value. This is to check whether you remember all those formulas correctly or not. Otherwise, you could have done that from the previous formula as well, but please calculate it using the dispersity. At least 1 or 2 answers I expect. PDI is for the final polymer, okay? Dispersity cannot be for a particular fraction, right? Dispersity means that how much amount is getting inside it, and how closer the value for MW and Mn are. So that can only be calculated at the end of polymerization. Okay, so I have got one answer, 14799. So as we don't have much time, let us see. Okay, you got it correct. The Mn value should be in the range of 14,800 around. Okay, so what we needed to do, as I have mentioned, I asked all of you to calculate the MW or say Mn value from the PDI value. So what is the meaning for, one second, what is the meaning for PDI? PDI is nothing but the ratio of MW and Mn. So PDI equals to MW by Mn. So how can you calculate Mn? You simply have to PDI, sorry, PD, my handwriting is horrible as usual. PDI divided by MW. No, sorry, MW by Mn. Mn is equal to MW by PDI. Just ignore this. MW divided by PDI. Mn equals to. Okay. Now once you know this, what are the things that are provided to you? Weight fractions are provided, MI are provided. You can very easily calculate the MW value. Just I have explained in the last one. You just need to calculate WI into MI for each of this fraction, and when you sum it up, it will give you the MW value. So this is your MW value, and your PDI value was given 1.5. So simply you needed to do 12,1200 divided by 1.5, and you will get your Mn value. Okay, so it will be around 14,800. Okay, so fine, there are many questions from previous weeks, so we will discuss them in the next session as well, because week 8 lecture materials are also mostly memory based. There will not be many numericals in it. So again we will discuss the numerical questions there. So all of you please try to go through the whole lecture for the next session, because I will be including question from all over the lectures, because that is important. Ultimately you have to remember the questions from all of it. And one thing for I want to say to all, I will post a message also, that is in the next session, any of you if have any doubt regarding any theory, any slide material, any numerical, please email me. Okay, because the next session will possibly be the last one. If I don't get any another doubt session, then that will be the last one. So any slides or any theoretical things or any numerical things, if you have any doubt, you feel free to ask me. Okay, up to assignment 7. Even if you have any doubt from assignments, from the assignments, then up to assignment 7 you can ask me the question as well. I will discuss them here, because that will be probably our last doubt session. Okay, so today recorded video I will upload it. Will take some time, but by midnight I think it will be done. Okay, I will upload the slides as well. I have to modify them a bit, but I will upload them again. Okay, let me stop.